If you finish your clotoid shape, you can draw another shape, plan of clotoid. You can draw that shape. How do you draw that shape? Before you draw this shape, investigate it. Look at the sample project. Look at key divided by 2. What is the key? It's ramp length. And look at these numbers. B is widenings, D is superelevation, H is elevation difference. Right side and left side edge highway cross sections, right side and left side edge elevation difference from road center line. You have to calculate all these widenings, superelevation and H values. How do you calculate that that all things? Look at, firstly, your highway must be widened end of the transition curve. This point is end of the transition curve, name of SC. This point beginning of the transition curve, name of TS. And look at these calculations. You for you can calculate your ramp length, you have to know your H1 and H2. For you can calculate your H2 and H1, you have to calculate your widenings. And after your widenings calculation, you can decide your H1 and H2. After that, you can calculate your ramp length. And after that, you can draw this shape and you can find your superelevations and widenings value, and you can calculate your elevation difference, so H values, according to basic proportion from distance from the SC and distance from the key, because from this area for this area has different proportion. After UA or TS, after TS, road has a different proportion for the superelevation and widenings. Of course, widenings must be after TS. Before TS, we have no widenings. And look at my values. Widenings formula is n L square divided by 2r plus 0.05 project velocity divided by root r. N is number of lane. In this project our road is 2 lane, and L is axial distance, is a 12 meters distance for the front wheels and rear wheels. Distance from the front rears and rear wheels of the car or bus. This, of course, is a bus, 12 meters, of course. And we know all these values. We know project speed, radius, and we can calculate widenings value for 2 lane 2 times, and my widening value B is 184 for 2 lane. Look at this, is for 2 lane. But for calculations of H1 and H2, we have to gain 1 lane, and this value divided by 2 equal 0.92 meter. After that, look at, for here is TS. Here is SC or UA, UE, sorry. Here is UA, UA, UE, TS, SC, same thing. For TS, road widenings is 10 meters. 5 meters. One lane, other lane, 5 meters. And H1, 5 meters times this point super elevation. What's that? 2% equal 0.02. And of course, it's a tangent value because super elevation is a grade, is a tangent. We want to calculate this H1 and 5 meters. Five times tangent alpha equals 0.1 meters. Yes. And endpoint SC, this point super elevation 8%. H2 equal, just like this, 5.92 times 0.08. As it's 0.474 meters. Okay, we know H1 and H2. After that, we can calculate key is a ramp length. What's the key formula? Here, key is 2H1 times LG, your transition curve length, divided by H2 minus H1. Yes, put values. 2 times 0.1 times 100 divided by H2 minus H1. Yes, this is key is 53.48 and key is 54. We choose this key value is the minimum key value. Minimum. You can increase the value. Yes, 54. After that, go to AutoCAD. This is our shape. This is clotoid shape. Yes, this is our clotoid shape. Copy. Copy. Yes. Five meters. Offset 5 meters. Yes. Draw the ramp length. What is my ramp length value? My ramp length is 54 meters, of course. And draw key path F8 button 54. Yes. Offset again 5 meters. Yes. Yes, we know every point for our transition on our transition curve. Yes, you can draw perpendicularly if your perpendicular object open in object snap settings. Yes. Extend from. Yes. Okay. We complete. We completed our clotoid plan, and after that point, we know this point is key. Take same. You can take same thing from here. Copy. Yes. And same thing. You can copy that. We cannot explode hatch. After that, but we can draw it from here. F8. Yes. From here 0. You can hatch this area with hatch command. Hatch. Hatch. Angle solid. Choose color. attach comment, and after after SC or UA, same thing. How do we find every point? How do we find every point widenings? So specify your as distance UA and A. Yes, A distance from the transition curve beginning 99 meters, and go from 99. This point is my A point. Copy. TS. Sorry, this point is TS. Sorry, this point is TS. Beginning of the transition curve. Yes. $54 meters. Yes. What is this point superelevation? comment of hash h. What's the A point superelevation? How you calculate that? Look at that. From here, it's a 4 meter. Yes, you have to measure it just like this. You have to show it just like this. And what's the proportion? This superelevation changing has a basic proportion. This is positive 2%, this is negative 2%, negative 2%, yes, and this is positive, positive, positive. This point super elevation, positive, positive. And how do we find this point super elevation? Is the super elevation change from -2 to positive 2? Changing is 4. What's the matter? Super elevation change 4% in the 54 meters. Super elevation change in the 44.1. What's the proportion? If the super elevation change in 44 meters, changing is 4. What's the 44.1 meters changing? Is direct proportion. Cool. X is so changing is 3.27 minus 2 plus equal 1.27. Yes, this point super elevation is, here is positive 2 of course, but this point super elevation is, yes, and draw it just like this. Of course, less than this from here. Yes, H. H. Yes.
Efendim? Ha, bu kadar. Yatırılacak vergiyi banka mı biliyor peki?
After TS, this point TS 1, 2, 3 and TO1. 1, 1, 2, 3 and TO1. After TO1 4, 5 H1 and SC 4, 5 H1 SC 4, 5, 4, 5, 4, 5 H1 H1 and SC or UE, same thing. Yes. From here, as the proportion, look at that. TS and one distance. As the distance from TS and 1, look at that. 8.26. What's the transition curve length? Is 100. What's the proportion? What's the proportion? What's the endpoint superelevation? Endpoint superelevation is 8. Yes. Copy. Copy. Yes. Of course, widenings. This point superelevation is 8. This point superelevation is 2. What's the changing? Changing is positive 2, positive 8. Changing value is 6%. What's the this point distance from the cross section 1? This is my plan, of course. What's the distance? 8.26. What's the proportion? If the superelevation in 100 meters, 100 meters change 6%, in 8.26 meters, what is the changing value? It's direct proportion. So x equal nearly 0.5. So positive 2 plus 0.5 equal 2.5%. Look at again, yes, 0.26, 8.26 distant. And this point superelevation is positive 2.5. This point superelevation, yes. more than this distance, of course, a little more than. Extend before, because it must be same tangent, same grade, same slope. And what's the value? 2.5. Yes. But this point has a widenings. What's the widening value? Widenings has the same proportion. Full widenings is 0.92 meters. What's the meters? In 100 meters, widenings is 0.92. In 8.26, what's the widenings value? Direct proportion again. 0.92 times 8.26 divided by 100 is equal x equal 0.0 meters. Of course 7.6 centimeters. Of course 76 millimeters. From here the widenings value. How we draw widenings? Just like that. Look at offset 0.0 offset again. Yes, just like this. After that extend from here. Trim yes, we know extending value. Extend yes, trim require and now require. Important thing is these lines extends, because these lines extends is changing. Hatch move hatch, so easy. But after you can hatch after the widenings. You can hatch after the widenings. From here, what's the super elevation value? We have to know distance from here. How we find that? Look at that. Down F8 24 37. in 100 meters, superelevation change 6% and 24 36 x meters, direct proportion, and x equal 6 times 24 36 divided by 100, 1.46, and so superelevation from this point superelevation is 2 plus 1.46. 2 plus, of course, superelevation is cross section 2, superelevation is 2 plus cool 3. Yes, this is superelevation at 2, cross section 2. 'What's the widenings at cross section 2? Same proportion, same basic proportion. In 100 meters, widenings value is 0.92. In the uh, 24 point, what's the widenings value? Direct proportion, basically, times divided by 100. Yes. Meters, of course. And just like this, offset 0 point, extend, and extend. Yes, not required. For cross section 3, what's the distance from TS? Yes, 37.32. In 100 meters, changing is to 37.32. What's the super elevation value? Again, you have to check. 37.32. Yes. And x is same thing, basic direct proportion. 6 times 37.32 divided by 100. X is 100%, of course. 2 plus 2 equal 4.24 for cross section 3 super elevation value, and what's the value? 4.24. 4.24, little more than that distance. Yes, extend. Four point 24. What's the widenings? Same basic proportion. In 100 meters, widening value is that. In 37 meters, what is the widening value? Direct proportion basic. Meters. This is our offset value, of course. After that, offset 3.43. Sorry, offset 0. Extend. This cross section is important. We have to extend only cross sections. Forget it, because after that point road is continuously widening. Portio, what's the value? What's the super elevation value? Of course it's 5%. Here is 9 required for now. If you want that, you can calculate the TO. Extend. Midpoint of the transition curve, of course, it has 5% super elevation value, must be. What is the widenings value? Total widenings is that. A midpoint, TO is midpoint. What's the widening value? Widening value is this half of this. Yes. Of course, 0.46 and offset 0.46. Extend. Yes. After that, this is not required for us for now. What's the 4 cross sections for superelevation? This is my plan. 4. 50 plus 70.77 minus 59.9. What's the distance? Distance is 60.87. What's the proportion? In 100 meters, superelevation change 6%. In 60 point superelevation change is basic proportion, just like this. I measured this distance. I measured this distance. After that, x equal 6 times 60.87 divided by 100 equal plus 2 equal 5.65. This point superelevation is 5 point 5.65. What's the Widenings value? Basic proportion, direct proportion. In 100 meters, Widenings is 0.92. In 60 meters, what's the Widenings value? X equal meters. The Widenings value for 4 cross sections. Offset 0.65. S extend S non require for now, and this point superelevation was the distance for 5. This is 50 plus 50 plus 83.06 minus 59.9 equal 73.16. 73.16 in 19 meters, sorry, in 100 meters, superelevation change 6%. In 73 meters, superelevation change values is basic direct proportion, same 6 times divided by 100 plus 2, of course. This point superelevation is, yes, this point superelevation. I calculated that. 100 in 100 changing value is 6%. In 73.16 meters changing value is 4.39. It's changing. What's the first superelevation is, of course, 2 plus 4.39 equal 6.39. Basic proportion. Basic. What's the widenings value? Same thing. In 100 meters, widenings is 0.92. This value. In 73 meters, what's the widenings value? Widenings is direct proportion, basically. Meters. This is offset value, of course. Offset 0. Extend. Yes. Late for now. It's not repair for now. What's the this points superelevation? How do we find H1 superelevation? Here is 50 meters. 50 plus 100 minus 59.9 equal 90.1. Our L distance until here from this point, beginning of the transition curve, is 100 minus this plus this line length. What's that? Of course, LG divided by 2. My LG is 100. LG divided by 2, 50. 100 divided by 2 is 50. 50 plus 100 minus this. We know this distance. Yes, my new distance from the beginning of the transition curve, 90.1. So what's the proportion? In 100 meters, superelevation change 6%. In 100, in 91 meters, what's the x basic direct proportion? 6 times 90.1 divided by 100. Plus 2, of course. This is the superelevation value for here. Extend. What's the value? 7.41. Yes. Yes. What's the widenings? Same proportion. Same proportion in 100 meters. Widenings is that. In 90.1 meters, widening is what? Basic direct proportion, same thing, times 90.1 divided by 100 equal meters. Of course, this is our offset value, of course. Offset 0. Yes. Extend and require for now. Yes. Endpoint. What's the endpoint per elevation? Of course, 8. Bigger than that. Extend. Copy. What's the Widenings value for the endpoint? Of course, it's that. It is our offset value 0.92. Offset 0.92. Extend. Extend. Yes. And for now, none required for us. Yes. Look at. Got the sample project. This is cutted. Of course, it must be cutted. change type dot what change the line type scale. Create again. Density, we have to increase density and go again. Yes, looks good. And we can draw widened roads for now. Yes, how draw spline feet from here, from here, from here, from here. So for the beautiful drawings, we have to create one more widenings line. What's the widenings value? 0. Dal, yes, 1 is the assumption, no problem. Copy and move. Yes, draw spline first point, second point, change the direction, space, yes, for here, again, spline, too little, be careful. After that, you can extend your Yes, we can hatch now. Hatch. Split the issue. Yes, we can hatch now. Hatch. Yes. Hatch. 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 This is you. Pull back that side. Hatch. If you hatch. 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 Yes, we finished hatched, and we finished all the super elevation plan, and you can write that, you have to write that super elevation, sorry, widening, super elevation and elevation difference. You have to calculate that. Of course, you can basically calculate that. You know all points super elevation, you calculated that, and you know all points widenings. Yes, not it of course, and you can write that super widenings be super elevation and hash. So simple, because what's this points widenings, that plus 5 meters, 5.46 times what's the super elevation, 5% times 0.05 equal your hash. Basic. You can draw that shape just like this. You have to do this. Goodbye.